Alrighty, so then you would just take the numbers that we just found with Excel at the end of the last video and you type them, and that makes your interval right there. And I know what you're thinking. You're thinking, hey, that looks familiar. Well, it should, because it's the interval we started off with right here. It's where I got the 7.7 from in the first place. I made that interval with Excel, and then I knew that the margin of error must be 7.7. We'll figure out how in a little bit. And then I was made this problem from that. So that's how we got those numbers that we end up with way down here. Okay. Now I know what you're thinking. You're thinking, well, Lana, that Excel thing, that was a little bit tricky because just because the formula is kind of yucky to type in, is there another way? Well, yeah, there are other ways in Excel. For example, I have Excel Stat, which is kind of an add-in that you can get, or DDXL, but DDXL doesn't work with the newest version that I can find. So what you could do though is StatCrunch, which, as you recall, is available here under Tools for Success in the course. There it is, Tools for Success. You click on StatCrunch and it opens it up. And what you want is stat, and this is proportions, so you're going to pick that. You're working with one sample in chapter 9 and 10. And you've got a summary. You don't have data, you have a summary, so click that. We had 30 red beans out of 120. Click Next. We're not doing hypothesis testing in this chapter. We're doing confidence intervals. So let me click that. And I wanted a 95%. And I click Calculate. And there it is. 172,327. And then I can always just copy and paste. I could paste it into Excel too if I wanted, but I could just paste it right here. It's not going to hurt anything. And for the future's record, just if ever you're wondering, StatCrunch is really cheap. Like you can buy for like $10 online. So if ever you're wondering, hey, I need a software somewhere along the way, StatCrunch is a nice cheap one. All right, so interpret this interval in the context of the situation. We are 95% sure, certain, confident, whatever you want to say, that the true proportion of red beads or beans, whichever, in the box is between 17.3% and percent and 32.7%. Now, let's talk about this for just a second. This isn't a probability. It's not like the chances of the true proportion being there. The proportion exists. This box is sitting in my office. Wait, hold on. This box is sitting in my office. It has a true proportion. We just don't know what it is. So I can't say, oh, the chances of it being, no. It doesn't have any chances. Either is or it isn't. It's either 100% something, like let's say it's 20%. So it's 20% or it's nothing. That's it. You can't have any options in between. So this is not a probability. This is a confidence. I am 95% confident that the true proportion of red beads in that box is somewhere between 17.3 and 32.7%. With me? Not a probability, confidence. Right? Am I 100% sure? No. How could I be 100% certain? Well, I'd have to pull every single bead in the box, which most of the time you don't have time to do. Okay. So what was our point estimate of the true red beans in the box? As you recall, that was my scoop, which was P hat equals X over N, which was 30 over 120, which was 0.25. So that was our point estimate. It's the center of the interval. It's the halfway spot between 173 and 32.7. So what's the margin of error? Well, you can find the margin of error a couple ways. One, you could just find it the long way, which is, let me copy this. Okay, so margin of error, way number one. You could just take out the 0.25 part and everything that remains, 1.96 times the square root of b1, which is 0.25 times 1 minus 0.25 divided by n.